Bismillahirrahmanirrahim. Students, I am Hussnain Ali from Bagh School, grade 12 and 13, chemistry teacher, A levels. Today, students, our topic of discussion is lattice energy calculation and Born-Haber cycle. So, what is Born-Haber cycle and why we need Born-Haber cycle? For the key points, lattice enthalpies cannot be measured directly. We have previously discussed in our previous videos that lattice energies cannot be measured directly, they have to be measured indirectly. So what is the methodology behind the calculation of the lattice energy? So lattice enthalpies can be calculated from Born-Haber cycle. So we have known that the Born-Haber cycle is used for the calculation of the lattice enthalpies. Our purpose or aim of our video is basically the calculation of lattice enthalpies from Born-Haber cycle. So Born-Haber cycle, what is it? It is basically a special case of Hess's law, that is root 1 is equal to root 2. You can correlate the Hess's law concept from the AS level chemistry energetics topic. Here the root 1 is depicting the direct root and the root 2 is depicting the indirect root. For the root 1, what we have to do, we have to make 1 mole of anionic compound from its elements. This enthalpy of formation is given here. Here you can see, I have given the example of the formation of the sodium chloride solid from its elements. The enthalpy of formation for sodium chloride is minus 411 kilojoule per mole. So this is our direct route for the Born-Haber cycle. So for the indirect route, that is known as route 2, what we have to do, we have to atomize and ionize each element in turn and then bring the ions together to make the ionic solid. So here you can see I have given the data for the sodium chloride formation. Here sodium solid is first atomized and its atomization enthalpy is given plus 109 kilojoule per mole. It is an endothermic process. Then sodium gaseous atoms are converted into sodium positive ions, 1 mole. This equation is relating the formation of the positive ions of the sodium. Here the enthalpy that is depicting this section, that is known as first ionization energy. Its value can be seen through the data booklet. While here the third equation is showing the atomization enthalpy of the chlorine in gaseous form. The atomization enthalpy is 121 kilojoule per mole. You can see this data also from the data booklet if it is not given within the question. Then we have to formulate the chloride negative ions so as to react sodium positive and chloride negative ions. So for that purpose we would be needing the first electron affinity of the chlorine, that is minus 380 kilojoule per mole. Lastly, sodium positive ions in gaseous state and chloride negative ion in gaseous states react to form sodium chloride solid, and this equation is depicting the lattice energy enthalpy or lattice enthalpy. Here this lattice enthalpy is to be calculated. This is a question from the A level past papers about the lattice enthalpy calculation of the sodium chloride and formulation of the Born-Haber cycle. So what are the key points relevant to the formulation of the Born-Haber cycle? Born-Haber cycles are often shown as energy level diagrams. Basically this is an energy level diagram. Here the endothermic is shown by upward arrows and exothermic process is shown by downward arrows. For the purpose of the sodium chloride Born-Haber cycle, I have drawn the Born-Haber cycle for the sodium chloride. You can see the yellow arrows are showing the indirect path, while the blue arrow is showing the direct path. Here sodium solid and chlorine gaseous react to form sodium chloride, that is our direct path, and the enthalpy of formation is needed in this step. That is our direct route or route 1. For the second route, we would be atomizing the sodium first. I have given the previous equations how they are atomized and what are their values. So when sodium is atomized, we would be needing the enthalpy of atomization of sodium. As you can see that the process is endothermic, we are moving energetically to a higher level. Then afterwards, then the chlorine is atomized and we would be needing the atomization enthalpy of chlorine. Further, the sodium is ionized and its ionization energy is required, that is first ionization energy of sodium to formulate sodium positive ion 1 mole in gaseous form. Then further going, we would be needing the electron affinity of the chloride ions or the chloride ion formation. We would be needing the electron affinity, that is first electron affinity of the chlorine. This is an exothermic process, that's why the formulation of the chloride ion is at a lower energy level from the previous step. Then the sodium positive and chloride ion in gaseous form react to form sodium chloride solid. Now this step is known as delta H lattice or lattice enthalpy. So our indirect route, that is shown in the yellow, is composed of atomization enthalpy of sodium, atomization enthalpy of chlorine, first ionization enthalpy of sodium, then first electron affinity of chlorine, and then we have to calculate the lattice energy in the indirect path, while our direct path is composed of only enthalpy of formation of sodium chloride, which is already given within the question. So composing whole of the data, we would be seeing that from the direct route is equal to indirect route, that enthalpy of formation is equivalent to enthalpy of atomization of sodium plus enthalpy of atomization of chlorine plus first ionization enthalpy of sodium plus first electron affinity of chlorine plus lattice energy. So enthalpy of formation is also given, enthalpy of atomization of sodium is also given within the data, enthalpy of atomization of chlorine is also given within the data, enthalpy of of ionization of sodium or first ionization enthalpy of sodium is given within the data booklet also. So the first electron affinity is also given within the question, and we have to find what lattice enthalpy. As we cannot calculate the lattice enthalpy directly, we would be using Born-Haber cycle methodology or the calculation so as to calculate the lattice enthalpy for the sodium chloride here. Here the lattice enthalpy for sodium chloride comes out to be minus 755 kilojoule per mole. You can see that it is an exothermic process because it is the formulation of the bonds or electrostatic forces of attraction between the sodium positive ions and chloride negative ions. So this is the calculation part, and previously the Born-Haber cycle drawn, it is basically asked within the paper to draw the Born-Haber cycle for a specific compound. So it comes out to be merely of 6 marks or 7 marks. Then further calculations are to be done for the lattice energy calculation, that is given for about 3 marks. So this is the whole question, how the question is asked about the Born-Haber cycle. Students, hopefully you have found this video very useful. Thank you. Allah Hafiz.